Hi, Miss Marion here. Go ahead and turn to page 129 if you have a normal one, or page 94. We are looking at Unit 4, Lesson 7. Go ahead and read the I can statement. I can determine whether an equation has no solution, one solution, or infinite many solutions. And go ahead and write yourself a sentence on how you feel about that and a number. So 1, I don't remember. 2, I kind of remember it. 3, I got it. And then 4, I can teach it to my friend. All right, so our goal for today is to be able to go ahead and figure out how many solutions something has. So it's either no solution, all solutions, or just one solution kind of thing. And so we're going to talk about a little bit further about that for today. Go ahead and turn to page 47 or 35, and you're going to say which one doesn't belong. So go ahead and pause right now, fill in the sentence frame, and you're going to write it underneath this question on page 47 or 35. So blank doesn't belong because of blank. Go ahead and pause and then come back to me. All right, is there a correct answer with this? Not really. Personally, I chose number 3, doesn't belong, because it has less stuff on the left-hand side. But as far as anything on this, you could have done number 2 doesn't belong because it's the only one with multiplication. And it's up to you as far as which one you wanted to. That doesn't belong. Pretty much it's just getting our brains thinking about math for today. All right, so this is not in your book, but I want to go ahead and talk about it. So you probably want to go ahead and write it down. And what we're going to do is we're going to kind of think about solutions. And notice how on this top one that we have 2t plus 5 equals 2t plus 5. And so we want to think of numbers that we can put in for t, and if we put in pretty much any number that we want into t, it's going to make it so that I can put any number in there. So the solution to this, so notice how does 2t plus 5 equal 2t plus 5? That is true. So this we can say is true, right? True, right? So then the solution to this is true for all values. The other way we can say it is it's infinite many solutions. So it has infinite many solutions. I can put whatever number I want in for t, and it makes it true for both sides. Or it's true for all values. Both sides is true for all values. Let's look at the one on the bottom. So we have n plus 5 equals n plus 7. Is this true? Does n plus 5 equal n plus 7? No, it doesn't. Okay, let's think about it. Let's go ahead and let's put n equals 1 in there. So we're going to have 6. Well, sorry. Let's start first. 1 plus 5 equals 1 plus 7. 1 plus 5 is 6. 1 plus 7 is 8. Is this true? No. And so is there any number, so let's think about it. Is there any number I can put in there to make it true on both sides? Well, that answer is no. This is not true. So it is true for no values. There is nothing I can put in there to make both sides true, or there is no solution. Okay, so we can think about it as any of these. So true for no values, the same as no solution. True for values, for all values, make it so it's infinite many solutions. You're going to need to know this to be able to do the next couple of activities and then also the homework for tonight. Make sure you write it down, okay? And then we'll go ahead and go to the next activity. All right, on page 50, what you're going to do is we have all these different equations. And you're going to sort these into true for all values or infinite many solutions, or true for no values or no solution. So remember how these kind of things go together, right? So you're going to put it into 2 different categories. And so I want you to go ahead and pause. I want you to go ahead and work through that, and then come back to me and we'll go over the answers. All right, so we have these in 2 different categories. Notice how the top part, it is true for all values. So let's look at it. Does n equal n? Well, yeah, that's true. Is that true or false? Well, yeah, that's true. So that's why it's true for all values. Let's do negative 6 times negative 3. Negative 6 times negative 3 is 18. And we also have it multiplied by y, which is 18y. Let's simplify the right-hand side. What's 2 times 9? That's also 18. And then multiply by y. Is 18y equal to 18y? Is this true? Yeah, so that means it's true for all values. Let's go ahead and simplify this next one. Let's do 2 times t. Well, that is 2t. 2 times positive 3 is positive 6. Does 2t plus 6 equal 2t plus 6? Is this true? Yeah, that's true. So it's going to be true for all values. Next one, let's go ahead and let's do the 5 minus 9. 5 minus 9 is negative 4, and then 3x. Let's do negative 10 plus 6. That's negative 4, also plus 3x. Does negative 4 plus 3x equal negative 4 plus 3x? Is this true? Yeah, it's true. So that's going to be in the true for all values category. Let's look at the true for no values. So is 1/2, let's look at it. Is 1/2 plus x equals 1/3 plus x? Are both of these sides the same? They are not. So this is true for no values because it is not true. So not true, no values. Let's multiply in our 3. So 3 times n is 3n. And then let's go ahead and do 3 times 1. That is 3. And then the right-hand side was the same. Is 3n plus 1 equal to 3n plus 1? Are those equal? Does that make sense? Is that true? No, it's not. That's why it's true for no values. Let's go ahead and multiply into 1/4. 1/4 times 20d. So grab your calculator. Let's do that. Let's do 1/4 times 20. That's going to be 5d. 1/4 times 4, that's 1. So is 5d plus 1 equal to 5d? Is that true? No, it's not. So that's going to be true for no values. Let's look at the last one. We have v plus 2 equals v minus 2. Are both of those sides equal? No, they are not. So this is true for no values. Hopefully this helps you understand the true for all values and then true for no values. If it's equal on both sides and it is true, that's going to be true for all values or infinite many solutions. If it's true, if it's not equal on both sides and it's not, then it's not true. It's true for no values or there's no solution that will make both sides equal. All right, let's go ahead and let's look at number 2. Write the other side of this equation so that this equals true for all values. Go ahead and pause right now and put something in that side to go ahead and make it true. All right, so I want to make both sides equal. And so there's a couple of things we can actually go ahead and do. Let's do 6 times u is 6u. 6 times negative 2 is negative 12. And then plus 2. Let's add negative 12 and 2 together. So we have 6u, and this equals negative 10. So remember, if it's true for all values, I want to go ahead and make it so that both sides are equal. So in that blank, I need to put 6u plus 10. Does both sides equal? Absolutely. So now it's going to be true for all values. Go ahead and look at number 3. Write the other side of this equation so that it is true for no values. Okay, so remember that means both sides are not going to equal. Go ahead and put something in there and then come back. All right, so let's go ahead. Let's multiply this in. Okay, so 6 times u is 6u. 6 times negative 2 is negative 12. And then we're going to add the negative 12 and 2 together. So this is 6u plus 10. So what's something that we can go ahead and put in there so that both sides are not equal? Well, I can put in there a 6u. Does 6u plus 10 equal 6u? No, that's not true. So it is true for no values. There's nothing that's going to be put in there so that both sides are equal. Ooh, could we put something else in there? Yeah, we can. What if let's see if I can get stuff to work. Hold on a second. There we go. What if we put in there, I don't know, let's put 2. The other part is also, if I put in 6u plus 10 equals 2, that means I can still solve for it. So I need to actually have like a u stuff in there. So really the only thing that really makes this work is that we have to have 6u in there. We have to have this, making it so that we can put letters in there and make it so that it's not true for both sides. So remember, we have to have letters on both sides, and the letters usually have to be the same, but notice how the numbers are different. On the right-hand side, I could do 6u plus 12. Oh, yeah, that works. So notice I have 6u on both sides, but my 10 and my 12 are different. Is 10 equal to 12? No. So is that going to work? No. So this is true for no values. All right, if we turn the page to page 51 and we look at this, it says complete each equation so that it's true for all values. And then I gave you kind of an example bank that you can choose from that you can go ahead and put in there. So remember, true for all values, I need a 3x on both sides, and then I want it to equal. Okay, so you're going to do A, B, and C, and then you can pick from the question bank. So go ahead and answer that, pause, answer that, and then come back to me. So what can we make it so that, remember, both sides are going to equal? So if we look at it, we go 3 times x is 3x. And then I need 3 times something, and it needs to equal to 6. Well, let's say 3 times something equals 6. Oh, that needs to be 2. Okay, all right. So now let's look at B. So we have x minus 2. So I want to have it as x minus 2 on the other side. Oh, there's a negative out here. That means it's really -1. So it's -1 multiplied by something and multiplied by something over here. I'm going to do the x part first. -1 times negative x is a positive x. Negative times negative is positive. And then I need a -1 times something, and this is true for all values. I need both sides to equal. So I need -1 times something is going to be -2. Oh, yeah. So I can also put a 2 in here. So -1 times 2 is a -2. Notice on the left-hand side, I have a -2. Right-hand side, I have -2. I have positive x, and then I have positive x. So what do we need in that box? I need a 2. So we need a 2 up here, and I need a 2 down here. All right, let's go ahead and let's look at C. Let's like simplify it more. So let's go ahead and let's do 15. So really what this is saying, 15 divided by x, so 15x divided by 5 minus 10 divided by 5. So what is 15x divided by 5? That's 3x, okay? What is 10 divided by 5? Put it in your calculator. Oh, that's 2. So really I need it as 3x minus 2. So I have blank minus 2. So what can I put in that box? I can put 3x in that box to make it so it looks like the other side. All right, here is number 2. It says complete each equation so that it is true for no values. Remember that we need the variables on both sides to equal, but then the numbers are going to be different. Okay, so kind of keep that in mind, and then you can go ahead and pick from the question bank to go ahead and answer A, B, and C. So go ahead and pause, answer those, pause, and then come back to me. All right, so let's look at A. So if we're looking at A, we have 3 times x. So we have 3x. So notice again, I need a 3x on the left-hand side, a 3x on the right-hand side, but the number stuff needs to be different to kind of make it false. So what can I go ahead and put in there? There's a lot of stuff I actually can go and put in there. So I don't need it to be a 6. So what if I do 3, and let's put a 3 in here. What's 3 times 3? Well, 3 times 3 is 9. So I do have my 3x on the left-hand side, 3x on the right-hand side. That's what I do need, okay, remember that? But then my numbers need to be different. So I have a 6 here. I also have a 9. there. Does that work? Absolutely. Okay. What else number could I put in there? What if I put a 6 in there? 3 times 6. What is 3 times 6? Oh, that's 18. So that's going to be like plus 18 on this side. Does that make it so that that is false? 3x plus 6 equals 3x plus 18. That makes it false. So it's going to make it true for no values. Okay, so we can kind of think of different numbers that we can go ahead and put in there. So let's go ahead and let's look at B. So on B, again, we're going to go ahead and we are going to take, again, this is -1 sitting on the outside. -1 times -x is positive x. Okay, so now I need to put a number in there so that it makes it so that it's not -2 or -2. So can I put 6 in there? Let's try it. -1 times 6 is -6. So do I have a variable on both sides? Absolutely. But are my numbers different? So I have a -2 and -6. So this makes it false, okay? So that makes it true for no values. There's no values I can put in for x that make both sides equal. So 6 works. Anything else I can put in there? Well, let's not do it as highlight. Let's do it this way. What about, what about -2? So we have -1, -2 minus x this way. So -1 multiplied by -2 makes it positive 2. -1 multiplied by -x makes it positive x. So is x minus 2 the same as positive 2 plus x? So x's are the same. This is a -2. This is a positive 2. Does that make it true on both sides? No. So that's a good thing as far as true for no values. All right, let's look at C. So remember, we're going to take the 15x divided by 5, 10 divided by 5, 15x divided by 5 is 3x, 10 divided by 5 is 2. So I need to put a number in there to make it so that it's false pretty much, and false for both sides. So what can we go ahead and put in there? So this one's going to be a little bit different. I need my 3x. Remember, I need a 3x on one side, a 3x on the other. But what if I do 3x plus 3 in that blank? So if I do 3x plus 3, I still have my 3x. What is 3 minus 2? 3 minus 2 is plus 1. So notice I still have my 3x on both sides, but notice I have -2 and a 1. So this makes it so that it is false. So remember, I still need the same variables on both sides to make this kind of work out. But notice how the numbers are different, so that it makes it false. It's going to make it true for no value. It's a little bit different. You might have to go ahead and pause this, rewind it, and look at it again. But notice how I can put something in that blank. I still need my 3x. So I could do 3x plus 6. I could do 3x plus 3. But remember, I still need that 3x in there on both sides of the equation. But we have to make it so that this end result, or this end number here, is not the same as -2. So today what we were doing, we were looking at true for all values equations. So that means both sides are exactly the same. We have like 3x minus 2 on one side. We have 3x minus 2 on the other. So that's going to be true for all values. We also call that infinite many solutions. Then we have true for no values. Remember, we have to have, so true for no values. Here, let's write this down because this one's a little different. No values. We need to go ahead and let's say we have 5x plus 2. I still need my 5x, but my numbers need to go ahead and be different. So 5x minus 1, so notice I have 5x on both sides, but my numbers are wrong. They're different. So this makes it so it's true for no values. All right, so go ahead and turn back to page 128 or 93. Again, we're determining if an equation has no solution, one solution, or infinite many solutions. The one solution equations is what we've been talking about all the way up until today. So we've been doing x equals 2, c equals 0. That's one solution. And then the infinite many solutions, that's true for all values. The no solution, that's true for no values. That's what we were talking about today. Go ahead and write an equation, write a sentence about how you feel about today. We are doing all practice problems that are in Canvas like normal. And then if you have any questions, go ahead and email me. Okay, have a good day. Thank you. Bye.